Every masterclass captain is coming. We start with masterclass captain 1, and you will speak 3 minutes, like a pitch, what you did in your masterclass and what was the outcome.
Okay.
And if somebody has a question, you can ask, but just one question. And if you have more questions, you know how he looks like, so you can meet him afterwards.
And maybe tell everybody again your name and tell us what the masterclass title was, and then you have your 2.5 minutes. Thank you.
So I am Alberto Vicent. I'm business intelligence expert at Celeros, and my masterclass has deal about the Korean supply chain, how to create the ecosystem in Korea to develop the Hyperloop. In Korea, the rail industry and the aerospace industry, it's know how it's amazing, and it's important that industries join Hyperloop. And to do that, all Hyperloop promoters, not only Celeros, have to tell them that the way of engaging is creating long-term agreements. We don't want to collaborate with Korean companies just for one standalone project. We want to do research together, to capture global opportunities together, and to together work and evolve Hyperloop. So that's basically the idea of the conference, the masterclass. But of course, we have talked about the Hyperloop status, when it's going to happen, the obstacles that we are facing, and we have done like an overview of the Hyperloop and the technological status, and it has been quite well. A lot of interest from the audience. It's been a pleasure to hold and to lecture this masterclass. So, and anything you want, you have my email, my contact. You can send me questions about whatever. And if there's a concept that maybe we have not deep down a lot, we can exchange mails and continue discussing. For me, will be like very good. So thank you for joining the masterclass.
Fantastic. Thank you so much. So email addresses, if you don't have them yet, Martin is happy to assist. Mr. Cho, I need you on stage. Yeah, it's always like everybody is, well, good that you are already here. So the way it works, we need the results from your masterclass. This was your, right? So should we will bring it to the stage. I can see that you actually wrote in big letters, so maybe we can even read it. So you have now 3 minutes to tell us what was the masterclass about and what was the outcome. So it's kind of like a small pitch so that everybody gets an understanding who wasn't in your masterclass what it was about. Okay. It looks like you had a lot of work to do. And I give you the microphone.
Okay. In my masterclass, we are talking about the high-tech tool for Hyperloop. Actually, as I introduced at the beginning, the older Hyperloop developers need, there is many things to do for all the component techniques. So we are trying to focus on to infrastructure. So infrastructure, as I talked about in the keynote speech, in the beginning, the setting is very important. So in the how to set up better than use the typical conventional technology is my question. And through the work with the heart, we can understand we can do better. So we can do better and with new steel and new types of tube. So that's the question. And also there is some possibilities of some using the various types of tube for the whole system. So, and also, is it already converged to one type of tube? So that's another question. So after that, we can find there is some option to realize to other better option to the various tubes of in the future. So this is questions and also some ideas about how we can solve this problem. What is the best solution, and what is the and also some not only just the tube itself, but there is some other part of flange matter with the forging, and also how to use other material with the combination. So through this kind of combination and new types of tube, we can improve the whole tube system. So that's the idea. And also we hope to find better, before setting up, we want to be more flexible than we can find. I hope to, there is many options to, before find out what's the best. That's the result of our masterclass.
Thank you so much, Mr. Shaw. Okay, number 3. Maybe I also get the other whiteboard there. Martin, can you assist me, please, with the whiteboard from Jörg? So basically, you just change. It's like a theater play here. We just change the background, and. Okay, then use one slide. If it's in the presentation, then it's anyways on your on this computer.
Yes.
Hey, fantastic. And this is also while Martin is setting up the stage. You should do that as a profession. Theater play.
Theater play.
Theater play. I see that was actually a very, wow. See, there's a lot of outcome. I know, and I heard from the others that you had a very productive session. I see something about transparent frameworks. So I give you the microphone.
Thank you. Thank you. 3 minutes. And counting down. Guys, I introduced 2 questions to my audience after this discussion we already had. One of them was, how could Hyperloop look like in the year 20-something? And we discussed very openly in a small but very competent round, I think, some of the scenarios they might appear. And we found out that one of the things which helped to overcome the situation of this bottom left scenario is about the green things. We turned the discussion into the red, so please concentrate on the green things. It's about trust to each other. It's about openness to new systems and maybe even openness to new legal systems. So we discussed we should even apply a legal framework not covering only Europe, but maybe covering the world. So we are transforming Hyperloop into a worldwide legal framework set. Acceptance of concentration on new systems, and which might result even in an abandoning of old systems. We should actively go, if there is one, if we've chosen one of the new systems like Hyperloop, then we should concentrate on these things. Here's a little bit more of internal stuff, but I'm limited to 3 minutes only. You can easily follow, because I wanted to draw your attention to the next idea about a consensus. So we also discussed some future scenarios. What can happen when the Hyperloop promoters are not agreeing on a certain extent? And we are focused. We are at the moment, at this point, we feel that we are coming close together. But what's the result? It might even lead to a consensus, but it might also to a breakout. So we really need to be careful. Sometimes it's really a dry topic, but it's important for further movement of our beloved technology. And the last input has been given by Professor Kim, who mentioned the amount of new technologies, steam engine, other ones, and this peak is going, according to his opinion, this peak is coming more often, more technology is being developed, but the elongation is not that high as it has been with steam engine. So he is afraid if we are losing the momentum at this point, nobody will be interested in any transport systems, because he's stating that nobody wants to travel anymore because internet is everywhere. So we need to be careful that we meet the transport demand. That's the outcome of the Hyperloop class number 3. Thank you.
Thank you so much. Martin, we had 2 more master classes. Was Mehmet, right? From Turkey. Turkey. Okay, I give you the... Yeah, well, you know, I'm from Berlin. We are little Istanbul. That is really the term. Like the Turkish in Berlin call it little Istanbul.
Oh, nice.
Yeah, there are third and fourth generation Turkish people living in Berlin. Yeah, and there are parts of Berlin where nobody speaks German, but everybody speaks Turkish.
Great.
So that's why I know. Yeah. Okay. So I give you the microphone, and you have 3 minutes.
Thank you. In our master class, actually I summarized in my presentation in the afternoon as well. We talked about large diameter Hyperloop tube mass production. We manufacture in 2 stages. We have a partner company. We are a joint venture. We are a joint venture with Çimtaş. It is in 2 stages. We develop we manufacture, for example, if we tell about the Hyperloop 2 TT project, 5 kilometers, we manufacture 250 tubes, each 20 meters, 4 meters, 0.5 diameters, and 25 millimeters thickness. We manufacture the tube from spiral welding, and in a very short time we can manufacture it. After we manufacture, we send it to, we put the first phase ultrasonic inspection and reinforce the rings and preparation for cutting and beveling. And in Çimtaş, they have expertise on detailing. Çimtaş is part of ENKA, is one of the leading big projects. They built one of the largest suspending bridge in the world in Turkey lately, and they built towers, wind towers. So their expertise in wind tower production, but they cannot produce in mass quantities. We produce in mass quantities. They put on the flanges, stiffeners, and they put the outlets on it. They prepare the surface for coating and metallization for forged flanges. So all inspections and documentation. So it will be ready for delivery. Also, we have almost 500,000 ton storage area in that facility, because these large diameter tubes need big areas. So we talked about this, and the questions were about cement tubes and steel tubes. What is good in cement and what is good in steel? As far as I see, 1 or 2 of 10 Hyperloop developing institutions, companies focusing on steel. 1 or 2 are, as far as I know, German. TUM now has their own cement pipe. And our Korean colleagues, we just checked that in Korea they prefer cement because of it's cheap to manufacture and transport. It still needs to be transported from factory to the site, but cement can be manufactured on site. That's why they also new cement characteristics, resistance to vacuum, and so But as I said, in our approach, steel, spiral welding steel manufacturing is cheaper, and you can manufacture in large quantities. So this is the result of our masterclass.
Thank you, Mehmet. Last but not least, Andrea, we have, yeah, actually even coming with some entertainment. As I said, that's kind of a theater play. Now the requisite, what is that? Improv. That's a cool improv. Are we doing now a comedy improv? That would be cool. Why not, right? I'm all up for it. I'm training for my stand-up. But it will be something personal about my private life in India. My Indian family loves already the pitch that I draw to them. But Andrea, I would say we make it now about your masterclass and about what we see here. And may I ask you to stay within 3 minutes? That would be awesome. So tell us, what was it about and what was the outcome? Thank you.
Hello. Hello, everyone. Yes, once again, my name is Andrea Sant'Angelo, and I'm a civil engineer. So my masterclass want to somehow summarize my exploration in this new world. So I come from civil engineering, bridge engineering world. So when I started in 2015, 2016, I didn't know nothing about it. And what I showed during my masterclass was all the process that make from a smart idea, like a brilliant idea, to be something real. So that many times doesn't happen, that the brilliant ideas became like a real project. So what I wanted to show in the masterclass, what was done, I mean, my side, of course, as a civil engineer, what can be done, what is done already, and what are the potentials of a Hyperloop system compared to the typical maglev system or high-speed rail system. So, but basically the things that I wanted to show among all the slides when I show the different materials, different shape, was the concept of a bridge that could be used for Hyperloop, but using the concept of a civil engineering typical cable-stayed bridge. But with the difference that instead the main deck is made by the tubes of the Hyperloop. So usually in the typical cable-stayed bridge, we have here the kind of cellular beams. But instead using the cellular beams, this could be the real tubes of Hyperloop. Could be in concrete. Okay, these are in concrete, but could be in steel, could be any material. But what wanted to point about in my masterclass, especially in the last part, is that in order to be Hyperloop a real thing, we must face the reality that even many times, many companies, they don't pay much attention, is the fact that civil engineering is quite important as the technology itself. Not because I'm a civil engineer, but because we must work together. Because many times it happened that I was working with brilliant people with brilliant ideas, but then they come to me and they give me like strange loads, strange components of forces coming from everywhere. And as a civil engineer, I cannot deal with these numbers. So at the end of the day, we have a brilliant concept of a Hyperloop technology that works very well. But then the civil engineering is so behind, and this gap sometimes make the brilliant idea not possible to be real. So what I am expecting in the future, and expecting with the next Hyperloop conference, is more focused with the connection of different engineering part of the project. So it's important that mechanical engineer important, thermal engineer important, aerospace engineer important, civil engineer important, because civil engineer is the last. But if even all three parts, or the other parts are okay, but the last one, the civil engineer, is at the end, must make all the numbers good to make this thing work, we will never go in any place. I mean, for example, this bridge, the problems we're calculating, the displacement that we have when when a pod is traveling. So, and then after like 3-4 months of simulation, so we discovered that still we have a vertical displacement very high. So, and then we started to study about it, how can limit this vertical displacement, and especially when the first pod comes and the other are coming. So if we have a cluster of pods. So the first one will be fine. But once the wave, the traveling wave across the bridge, we have like incredible movement here because we have a resonance here. How can we fix it? So, and then when I was showing these results like a couple years ago, I mean, we arrived in nowhere. So I say, what do we do? I mean, we have a resonant problem. What do? We do dampers. We change the frequency. We change the bearings. So at the end, we stopped it, and we said, okay, maybe we have to change something. So in other words, is what I want to say is this work must be done. I mean, it's a circle. So with the approximation, progressive approximation. So we fix the problem, like, I don't know, the thermal problem. Okay, now we fix the mechanical problem, but then we have to fix the engineering problem. If the engineering problem doesn't work, the thermal engineer must work again. The mechanical engineer must work again, because otherwise we go nowhere. So at the end, we arrive at this bridge, for example, we know that up to 400, 500 kilometers per hour, a structure like this can work. Actually, the structure is 150 meters long. So how can we pass this? So we discovered that maybe we can make the slower when we can slow down, but it's not acceptable. Or maybe we can, and another problem, for example, just a reminder, what if a pod traveling one side, the pod traveling in the other side at the same time on a structure? So it's another incredible problem. I was working this in a different field. I was working when my career was more bridge engineer. I was working in New York City for a Parsons, a company, bridge company. And there was a problem in a bridge because when the Manhattan Bridge, when the train were coming one direction and going in the other direction, there was a torsional instability that make a huge problem. And, you know, in that time, and then what they solved, they said, okay, the train cannot go in the same time on the bridge. So, I mean, but I mean, we are talking about old bridges. I mean, we're talking Manhattan Bridge was an old bridge. So, but again, just to make it short, I would be very happy if one day we'll be more focused on civil engineering, because every time I speak about civil engineering on Hyperloop, looks like it's something that the general contractor have to deal, but it's not true. I mean, the companies, I mean, the big players are all here. I mean, I know all of you guys, that they're brilliant guys, but I hope you are focusing, I don't know in detail what are you doing about the civil engineer, but I hope that you are focusing enough to make these kind of problems, I mean, solvable from the civil engineer part. Otherwise, even everything else work, at the end of the day, we cannot like make this thing real. That's all. Thank you so much.
Thank you. Thank you so much.